Welcome back, everybody. This is our video solution to problem 6 from quiz 9, fall 2023, math 307, linear algebra at Cal State Fullerton. In this problem, we are given a subspace of R3, we'll call it U, and it's the span of two vectors, 3, -1, 0, and 1, 0, 1. And our goal is to find the orthogonal complement of U with respect to the standard inner product on R3. All right, so again, we will recall that the orthogonal complement of a set, or subspace in this case, is going to be the set of all V in the vector space. Here, that's going to be R3, such that the inner product of V with any vector in U, and I'll just write capital U here, is equal to 0. And by this I mean V with everything in U. Okay, now what is everything in U? Well, it's the span of 3, -1, 0 and 1, 0, 1. So this is equal to the set of all V in R3, such that the inner product of V with the span, right? So anything in the span of 3, -1, 0 and 1, 0, 1 is equal to 0. Okay, so if I take the inner product of V with something in the span, then, well, this something in the span is going to look like a linear combination, right? So it's going to look like some A times 3, -1, 0 plus some B times 1, 0, 1, where here A and B are real numbers. Okay, but I know that the inner product has first argument linearity, and since we're working over the real numbers, it even has second argument linearity. And so I could break this up, right? I can break this inner product up as the inner product of V with 3, -1, 0, and I'll pull the A out front, and the inner product of V with 1, 0, 1, and I'll pull the B out. All right, so that's what this piece here is equal to, right? This piece right here. So I'm looking for all V such that this linear combination is 0 for all A and B. But this is actually now just a linear combination of, well, they're two real numbers, right? I could actually write this kind of a funny way. This is all V in R3 such that the span of these two real numbers, V, 3, -1, their inner product, and the inner product of V with 1, 0, 1, that inner product, that span is just equal to 0. All right, and of course this is the R span. Okay, well, the only time you're going to take the span of two real numbers and just get 0 out of it is if each of those individual numbers is 0. So this is just equal to all V in R3, such that the inner product of V with 3, -1, 0 is equal to 0, and the inner product of V with 1, 0, 1 is equal to 0. Okay, so let's on the side now just say, well, what if I called my V X, Y, Z? In that case, what would the inner product with 3, -1, 0 be? All right, so I'm supposed to get 0, and the inner product would be, well, 3 times X minus 1 times Y plus 0 times Z. And the second inner product, I'm supposed to get 0, and I would get 1 times X plus 0 times Y plus 1 times Z. So the first equation tells me that Y is equal to 3X, and the second equation tells me that Z is equal to -X. So those are the triples I'm looking for. They look like X, 3X, -X. So this is all triples, X, Y, Z. Actually, I don't need Y and Z anymore. X, 3X, -X, where X is in R. Okay, and now I can just factor an X out of this, And I get x, 1, 3, negative 1 over all x and r. But this is precisely equal to the span of one vector, 1, 3, negative 1. And there we go. We have found the orthogonal complement for u. It's one-dimensional. This isn't super surprising. We know that R3 should be the direct sum of u and its orthogonal complement. And u is two-dimensional because, well, it's a span of two vectors, neither of which is a multiple of the other. So this is definitely a two-dimensional space. And so the orthogonal complement should be one-dimensional, right? Because R3 is three-dimensional. Okay, so this checks out. All right, there we go. All right, I hope this is helpful, and we will see you next time.